For this page 2 and 3 in this packet here with this International Space Station motion, ISS International Space Station, we have this essential question: is there a force acting on this International Space Station? So that's our question that we're asking. So when I'm asking us here, describe what you saw, what forces are acting, what I want us to try to get to is this video here, and I'm asking you to describe what you're seeing here. So as you look at to see what's happening, I want you to describe what you're seeing here. Also, when there's these astronauts in space, I want you to describe what you're seeing and what you're seeing here. So this is what I'm asking that you describe when you try to describe what you see, and then trying to say what forces are there. So, is there a force acting on this International Space Station? Yes, there is. There's definitely, and I'll even give us a little hint, is that there's gravity here. There's going to be gravity definitely acting on this International Space Station. So describe what you saw, what forces are acting on this. You should be able to say that there's gravity. If there are forces, the force pair, well, there's gravity from the Earth acting on the space station. That means the space station also has gravity pulling on the Earth. So when we get to this path, when you're trying to draw out the path that this International Space Station makes, we're going to have Earth, and it's going to go in this path of a circular orbit going around Earth. So we have this circular orbit going around Earth. And when we get to the force diagram, we have this force diagram where I have this force due to gravity acting on the space station. And if we were to have this go in this path, getting over to this point, when it's in orbit, it's going to have this force due to gravity. And then when it keeps going in orbit, at this point here, it's still going to have this force due to gravity always pointing towards the Earth. It's always going to have gravity acting on it towards the Earth. So as you're watching those clips, what is constant? And so out of these mass, speed, radius, and velocity, I want you to tell me which one is not constant. Mass, speed, radius, and velocity, one of those is not constant. I want you to be able to tell me which one is not constant. So, what do these astronauts feel inside of the space station? Well, there's definitely going to be gravity. Without gravity, that space station would fly off. They don't feel the floor. That's the difference here. This is just like when we went to the elevators. When we went to the elevators and the elevator was falling underneath us, we didn't feel the floor. We felt weightless because there was no normal force. And so when people say there's no gravity in space, they're talking about those astronauts floating around. Well, there's definitely gravity. We're going to see that there has to be gravity pulling towards the center because they would just fly off in a straight path away from the Earth. And what they don't feel is the floor. And so the astronauts, they feel this force due to gravity pulling them straight down, but they just don't feel the floor pushing them up. That's why they look like they're weightless. It's because they don't feel that normal force. They don't feel the floor. So, as we get to now this page 3, we have this intro to circular motion, and that's where I want us to look at the notes that we have here, and as we try to describe the direction of the force, as you click through, you can see that we have this perpendicular force acting on the objects, causing this to turn, and we have this centripetal force here. It's always pointed towards the center of the circle. So if the force is pointed towards the center, that means the acceleration is also always pointed towards the center of the circles. That's what the centripetal force is saying. It's the force and the acceleration are pointed towards the center. And so when we got to describe the velocity, we see that the motion here is always perpendicular to the force. So when we try to describe the velocity, the motion is always perpendicular, so that velocity is always perpendicular. And then when we're trying to give out some examples, we can use this guy here throwing the hammer in the Olympics, and he has this centripetal force. This is an example, a salad spinner, or if anyone's ever done the bucket over the head, electron spinning a nucleus, a dryer, or the object in gravity, or that really fun, awesome thing at playgrounds that are no longer there. gravity on Earth, or this cool amusement park ride where if you've ever gone and you have the floor falling from underneath you. And here we have this string that's causing this rock to go in a circle. And just like if gravity wasn't there, the space station would just fly off in a straight path. But we see that the space station goes in this circular orbit, so there has to be this centripetal force, because if there was no force, just like the string to break, that object would fly off in a straight path. So when I get to this, what made the rock spin and what made this planet spin, you can use the notes to answer what made the rock spin, but here I have this Balearic sling, and you can look to see, well, how does this operate and how does this work? And then the planet, when you're dealing with the planet, that's where we have this right here. So when I'm asking about getting this planet and trying to get the planet to go in orbit, you can click on this gravitational force, click on this velocity, and click on the path. As you click on those, then you can see the path that this is taking. So when it's asking us what path does the planet make after the centripetal force is gone, you can turn gravity off by switching off over here. So if we had no gravity, then you can see what would actually happen when we have something with no gravity. And so you can see what actually happens with no gravity. And what makes there actually be this force, and where we have this force due to gravity acting on the Earth, and the Earth is pulling on the sun, or if you can think about the satellite, the space station, same thing here. If we turn gravity off, bye space station, bye astronauts. So try to finish this up.